Exercise a04 is an extension of exercise a03. We're going to add two functions to our resizable int array miniature library, okay, or abstract data type. The first one is going to allow us to resize an array, so we can shrink it and then we lose elements, or we can actually increase the size of our resizable int array, and then we'll have more room to store more elements, or we can simply specify the same size. In that case, the function will have nothing to do. I will simply return immediately. The second function we're going to add is a raya underscore clone function, which we are used to develop that kind of stuff now between the little string library and stuff like that. So pretty much we get a structure which is a raya underscore t star, and we are going to look inside of it and we are going to make a copy of everything that is there. We allocate a copy of everything, including the structure itself, and we return its address, the address of the newly allocated structure. So we are going to start by that one. We're going to start by the clone function. So let me open once again a text editor on our code. I already added here the two prototype for those functions in raya.h. We are going to go into raya.c and we are going to start working on our clone function. So right now it's not doing anything. Okay, I have just boilerplate code here. The function is simply returning null. Okay, and that's about it. So let me re-indent this. This was a cut and paste, of course, of the prototype that we had. So I'm going to re-indent that appropriately. Okay, and now we can start the real work. Alright, so what do we have to do when we clone a structure? Well, we know that inside that structure we have a field, a PTR, which is a pointer on a dynamically allocated array of ints, so we'll have to clone that as well. And we have a field which is size, which we can just copy. It's an integer, okay? We are going to copy those fields, and we're going to copy them in a new structure. So we could call malloc to create a new structure, okay? So we could here declare that we have a raya t star p, and then do a p equal malloc, etc. Instead of that, let's reuse what we already have. Okay, we have here a raya create function, which we can use to create a resizable int array data structure. So let's use that instead. Raya create parentheses, and then we have a look here at what the parameters are, and I'm going to collapse all those functions so we can see more easily what we are talking about here. Raya create needs the size. Where am I going to find the size? This arrow size. And then it needs a default value. I'm going to use 0. I'm not told to use anything else, so why not? And then you realize that you are dereferencing a pointer. So here's your reflex. You dereference a pointer. Is there any possible chance that this pointer is invalid or null? Well, I don't know. It was given to me as parameters. So I am going to do some error handling here. If this equal null, then return null. I have nothing to do. You give me a null pointer to a data structure. You want me to make a copy of that data structure. There's no data structure. There's nothing to do for me. Okay, so first error situation out of the way. If this is not null, then I can dereference it, access the size field, and therefore I can pass the size to raya create and ask for a default value of 0. Once I have done this, raya create, let's go back to the code here to double check it, is allocating the structure and calling raya init. Alright, let's go and have a look at what raya init is doing right here. It sets the field size, it sets the field PTR by allocating a new dynamical array of integer, and it sets each of those integer to the value that was specified as default value. So pretty much here, I don't have much else to do. Okay, I created my clone. Now what I need to do is transfer all the integers that are in the current data structure to this new clone. So this is going to be a counter-controlled loop for I equals 0, I lesser than this arrow size, I plus plus. What do I need to do for each iteration? P arrow PTR. Okay, this is actually my pointer on a dynamical array of integer as allocated here on top. Well, P arrow PTR index I equal des arrow ptr index I. I copy each of the integer one by one in my clone. Once I'm done with that, instead of returning null, I need to return p. Okay? If Raya create cannot allocate anything, what does it do? Well, here I call malloc, and I pass it directly to Raya create, which uses it blindly. So this is actually poor code. Okay? What I should say here is if p equal null, then return null. I could not allocate anything. In Raya init, similarly, I should say if des equal null, return nothing. It's a void function, okay? And when I allocate my des arrow ptr, instead of using it blindly and thus causing potentially a problem, if des arrow ptr equal null, well, what do I have to do? I could not allocate memory for the array of integer. I'm going to return out of this function. I could exit the code at that point, okay? None of them is really a clean solution because if I exit the code, well, this is not really a library that nobody wants to use in their application since it crashes a whole application as soon as something goes wrong. And if I just, if I just ignore the error and return, then since I don't return a code error, this is going to be also kind of a bad choice for a real-world application. So keep in mind that here we're keeping things simple, okay? If you had to develop that kind of code in a real-world application context, you would probably have to use signals and exception here to just have a cleaner way to notify the code that is using your function that something is wrong. But we're not going to go into that just about now. So, okay, we have here the copy code. Let's save. Let's go into a terminal and we're going to try to compile this. JCC raya.c main.c. Couple of things to take care of. Line 9, implicit declaration of function malloc. So that should be easy to fix. That just means that I should here use pan include stdlib stdlib.h to be able to use the malloc function. Try to save. No new line, I just got that. At end of file, this is also something that is trivial to fix. There we go, so let's fix it in the same shot. Implicit declaration of function exit and implicit declaration of function RIA Raya display line 9 and 11 respectively. So this is in the main, and I just realized that my raya.c is not saved properly. So I'm going to go back here and save it. I'm going to go to main.c and take care of those errors here. Can include stdlib.h. And what about the Raya display, which is line 11, which is now 12 because I added a line. Raya display is a none. Let me go to raya.h. And I don't see it indeed. So raya.c. Let's go back up. Raya create, value, get value, display. I'm going to make a copy of the prototype, put it in raya.h. Let's put it first. Space it to align it with the other prototypes. And we are done. Save. Let's see what the compilation yields to. It looks like it's working. Execute the code. We are not using clone yet, but I just want to do pretty much regression testing. So the code is displaying 000090. Let's have a look here. Raya create an array of 3 integer initially assigned to 0. Well, Raya display it, so this is 000, this is correct. Then set the value at index 1 to 9, display it, index 1 is here, this is correct, nothing changed. Then get the value and check if it's different than what we expect. It's not. Destroy, check that the pointer has been set to null. Display an error message if it was not. Nothing appears on the screen, so everything is working fine. Now what we need to do is before Before to destroy everything, it would be a good idea to test our clone function. So I'm going to have a raya t star p here. P equal raya clone, and I'm going to ask it to, and I'm calling it p. Oops. Let's call it my clone. So my clone is going to be a copy of the data structure pointed to by p. And just to visually verify that everything is working, I'm going to do a raya display of p. This is redundant, but you'll see why I'm doing that. Raya display of my clone. And I'm going to add printf testing cloning function. Little typos everywhere here. Testing cloning function, new line. Printf original structure is, and I'm going to simply display here. I'm simply going to use raya display of p, and then I'm going to do a printf copy of original, and I'm going to use raya display of my clone. Okay, let's save. Let's check for a syntactical error first. Let's try to compile. Let's try to run. Testing cloning function, original structure is blah blah blah, clone is blah blah blah, and I realized that to make it just a tad more readable, I could use a little tabulation here. So nothing critical, I'm just like being picky about the layout of the display here. And there we go. So we have our test for the cloning function. Now we're going to move on to the next part of this exercise, which is the raya resize function. So we have a bunch of stuff to verify here before to even decide if we have any work to do. So let's go to raya.c. Let's go to the resize, and let's get rid first of everything that can go wrong. Okay, every opportunity we have to not have anything to do. If pdes equal null, and this is kind of a reflex. Okay, if my pointer is null, I cannot work. Now, pdes, as the name implies, a pointer on pointer. So if star pdes is null, well, I'm not going to work ever. Nothing I can do if you give me the address of a pointer on a raya structure which doesn't point to anything. So I get rid of the obvious, okay? And now if I go back to the exercise definition, what do we take care of? We take care of make sure the pointers here are valid, non-null. Make sure the size is a strictly positive integer. Well, we are trying to resize, so we'd better make sure that, you know, we're not trying to resize to a dynamical located array of size -3, because that would not make much sense. So if size is lesser or equal to 0, then return. And there is much more we could do here as error handling. This is really like quick and dirty, but let's go for it for this right now. Other things that can go wrong. Well, if the size is the same as the current size. So how do we get the current size? Well, star pdes is leading us, assuming that you can type a star pdes is leading us to a pointer on a raya t data structure. So I can use a row to access one of the fields. The field that interests me is size. If the size that is given to me as parameter, which is actually spelled new size and not size, as I kept using so far, if the new size is equal to the current size, nothing to do. Return. What else can go wrong? Well, then the new size can be smaller or bigger, but then I have some work to do, so I cannot get out of working that easily with this. If the size is the same, then you have nothing to do. Well, we took care of that. We took care of the first bullet item. Now starts the work. We need to reallocate an array of new size integer and copy as many elements as possible from the old array into it. What does that mean, as many elements as possible? Well, that means that if the array is smaller, we're not going to be able to fit everything that was there before. Okay, so let me get this out of the way, this terminal out of the way, and we are going to work here on this function. Alright, so we are going to distinguish two cases. We're going to distinguish, we try to increase the size and we try to reduce the size. Regardless, here's what I'm going to do. I'm going to say that I have a temporary pointer on integer. So, well, yeah, let me think here. Let's go with p. Int star p equal malloc size of int times new size. I don't know if I'm shrinking or expanding, but right now I just know that I need a new array of that size. I'm going to arbitrarily, because this is not specified in the question, I'm going to say that I lesser than new size. I'm going to say that all elements of this new array, p index I, are going to be set to 0. Arbitrary choice, it was not asked of me, but I'm going to just do that to clear my memory. I could have used also a different memory allocation function, which would have reset all of my element to 0 for me automatically. But let's use only malloc and free right now. So once I have this new array of integer, I'm going to determine if new size is greater strict than star pdes arrow size. If this is true, this means that I am in for some increasing, which means I have enough room in this new array to copy all of the elements of the current array. For I equal 0, I lesser than the size of the current array, I plus plus, and there is an extra parenthesis here. Well, what do I have to do for each of those elements? P index I equals star pdes arrow ptr index I. Okay, so I'm making a copy of everything that was in the old array into my new array. Okay, and then what about the extra space? Well, it's initialized to 0. Okay, so you have this loop, so I don't have to worry about it. There's just a bunch of 0 after it. Let's leave it at that for now. What is the else part? The else part is new size is actually strictly inferior to the current size. So what I'm going to be able to do is copy the new size first integer from my current array into the new array and no more. So this is going to be this time using the new size as the number of elements to copy, and the copy is going to look pretty much the same. Arrow ptr index I. Okay, what else? Well, I just made a copy of a certain amount of elements. Okay, in the first case I copied all the elements and I have room left. In the second case I copied only the first new size elements of my current array into the new array. No matter what was the case, I need to deallocate star pdes arrow ptr. I don't need it anymore. Once I'm done deallocating this guy, I'm going to replace it by my temporary newly allocated array. Then I'm going to say that the new size of this field is the new size I've been using here. Semicolon. So that happens regardless of whether I added some elements or not. Review quickly the code. I call malloc here if p equal null. But if I cannot allocate a new array, return from this function. Otherwise, start doing the job. Okay, let's give it a spin as it is. Save. Open the terminal. We are going to recompile to make sure this is syntactically correct. And we don't have a call to that function yet, but let's do some, regression testing. I don't have the call yet. Everything is still working. I didn't accidentally, alter a character in one of the other function. So now I can focus on testing this new function. I'm going to go into the main. I'm capable to resize things. Okay, so I'm going to go before the testing of my cloning. And I'm going to try to resize my array to increase its size. So printf testing resize functions \n. And I'm going to start by increasing the size. New size equal, we have an array of size 3, let's go for an array of size 5. Okay, and let's display the result. So I'm going to call Raya resize. The parameters are going to be the address of P, and I realize that I inserted my stuff here at the wrong spot. Let me get rid of all of this first. There we go. Oops, could have copied a little more. Let me take everything that goes with the cloning and put it right here. I will do. And we are going to test the resize function, and we're going to have everything that goes with the resize going on here. So I'm passing the address of P to resize the structure pointed to by P. I'm going to say the new size is 5. So if I look at raya.c, that means, well, that's all I need as parameter. It's just going to try to increase the size here. So my size is going to go to 5. It should be padded with zeros. Okay. I'm going to display the resulting resize array just to make sure that we have an array of size 5 now and that there are a couple of zeros added. Once I'm done with this, printf new size equal, well, let's revert back to 3, so the rest of the test will be unchanged. Okay. Raya resize address of P. We go back to 3. Raya display our new data structure pointed to by P. Okay. Well, we are pretty much in good shape for the test. Here we have some sort of minimal testing going on there. Let's go back to a terminal. First compile. Syntactically everything is fine. Let's try to run it. Testing the resize function. Our array was 090. Size 5, added with 0. Resize it to 3. The 2 0 that we added disappear, and then we can keep manipulating our array like we did before. So pretty much at that point, the code that you have here, the test code, and the code that we added for both functions has been completing the objective for this exercise.